Hey folks, Mr. Bullock here, and this Algebra 2 lesson slash pre-calculus lesson is a review on conics that are centered at the origin. Okay, so let's go ahead and just start graphing some of these, you guys. So let's graph each equation and identify all the parts. If they have focus, we'll identify those. If it has a parabola, we'll identify the directrix. And let's see, what else? Let's see. Oh, the hyperbolas, we'll have to identify the asymptotes and all that. Okay, here is a parabola. This is a parabola because only one of the variables is being squared. Okay, so I know it's a parabola, and I know it's a parabola that's going to the right because the y is being squared, and it's positive. Okay, remember when you're in Algebra 1 class, when your Algebra 1 teacher asked you to graph y equals x squared, and it gave you a nice parabola that went up like that. Well, when x is being squared, it's going up or down if it's negative. If y is being squared like this one, it's going either to the right or to the left. And since everything's positive, this one's going to the right. Okay, so I know it's a parabola, you guys. So and it's in the form of y squared equals 4px. So the textbook I'm using, they like to write it in this form right here. An old textbook, they wanted you to write it and how to go 1 over 4cx, something like that, or x equals 1 over 4cy squared. In any case, whatever, they graph the same, you guys. The textbook I'm using, the Algebra 2 textbook I'm using, is they want you to write it in this form, y squared equals 4px. P is your focus point, you guys, so it tells you where your focus is off the center. Okay, and this one's centered at 0, 0. So this 4p right here represents this 18x. So I let 4p equal 18, so p equals 4.5. Okay, so it's centered here at 0, 0. So if I go over here at 4.5, that's the focus point. And remember, the parabola is going to surround the focus. It protects the focus. Okay, it's the focus protector. And the directrix is going to be a line back here. Okay, so whoops, I remember I didn't write the axis of symmetry on this one right here. So here's the vertex at 0, 0, and here's the parabola. Just draw a general. It's a pretty wide parabola because if I divided both sides by 18, it would be x equals 1/18 y squared. The 1/18 tells me it's very wide. In fact, it's wider than this right here. It would be going way out here. I just didn't have enough room on my graph right here. But I do know that this parabola surrounds the focus. I know the focus is at 4.5 or 4.5 comma 0. Okay, and this is a horizontal one. And the directrix is this line over here. Okay, remember the vertex is always in the middle. Your directrix is behind it, and your focus is inside the parabola. Okay. All right, so here's another one, you guys. X squared over 144 plus y squared over 256 equals 1. All right, this guy is an ellipse. It's already set up in the equation that we want it to. I know it's an ellipse because that's a plus sign right there. And the x is being squared, the y is being squared, and these are different numbers. If they are the same numbers, it would be a circle. But that's a plus, those are squared, so I know it's an ellipse. Okay, so everything's ready to go. So on ellipses, we look for the bigger number. The y squared has the bigger number, so that tells me this is going to be a vertical ellipse. It's going to be an ellipse that looks like a football kind of standing up right here. Okay, and let's see, my vertices and my co-vertices. So let's see, what did I say there? Yeah, since the bigger number's underneath the y squared, it's a vertical ellipse, and then square root underneath the y squared, and that tells me where my y-intercepts are. Square root underneath the x squared, and that tells me where my x-intercepts are. So my x-intercepts are at plus or minus 12. So those are called the co-vertices. So at negative 12 and positive 12 are the co-vertices. And then square root of 256 is 16. So at 16 and negative 16 are called the vertices. Okay? All right, so there's those guys right there. So you can go ahead and graph here. It's almost a circle. It's not quite a circle, but it's an ellipse, you guys, more like a rugby ball. Okay? All right, so make sure you get your ordered pairs correct. Okay, verticals have start with 0, horizontals have 0, and the y coordinates right there. Okay, so we need to get the focus points. Since ellipses have plus signs, your c squared formula has a minus sign. And those are your a squareds and b squareds. Remember, your a squared is your bigger number. So 256 minus 144. So that's c squared. And so since this is vertical, then my focus points are going to be vertical. So they're going to be on this y-axis. So they're going to be 0, comma, plus or minus the square root of 112. I'm going to assume that you know how to simplify 112 to get 4 root 7. Okay, and 112, the square root is about 10.6. So there they are, focus 1, focus 2, and then I'm just going to go ahead and connect it. And I'm here at home on my laptop, so I'm doing this with my finger, my index finger on my little screen right there. So here's my ellipse done by my finger. That's not bad, huh? I almost couldn't do a better job on my Promethean board at school. Okay, you'll see my sucky circle coming up though, you guys. So, okay, so this one here, you guys, is this one is a hyperbola because I know they're both being squared, and there's a minus sign right there. And hyperbolas, we want them to equal 1. If it wasn't equal to 1, and same on the last one, if it wasn't equal to 1, I divide it by this number to make it equal to 1. Okay. All right, so this one is a hyperbola, you guys. So hyperbolas, we want to know which one comes first. I don't care about the bigger number. I want to know which one comes first. The y squared comes first. So this is a vertical hyperbola, which is going to be a parabola going up, and then the mirror image is going to be going down here. Okay, so let's go ahead and get started. It has y-intercepts only, you guys. My y-intercepts are the vertices. Square root that guy. So plus or minus 5 are my y-intercepts right there. Okay, so those are my vertices at plus or minus 5. And this is vertical, you guys. You got to recognize it's vertical, so it has the vertical coordinates 0, comma, plus or minus 5. Okay, if x squared came first, it would be plus or minus whatever this was underneath here, comma 0. It would be over here. But since y squared comes first, it's vertical. Okay, now we got to draw the box. Okay, so the box, oops, I did my asymptotes here for sorry, tongue twister. My focus points I did first, you guys. So since hyperbolas have minus signs, my c squared formula has a plus sign. So again, this is a squared, this is b squared right here. So you add them together, you get square root of 146. That's 2 times 73. So that doesn't simplify, you guys. So your focus points are 0, comma, plus or minus the square root of 146, which is a little bit past 12. So there they are right there. And then, so now we're going to do my box here. So my box is always, I always do the x's first. So square root 121 is 11. So I go to the left and to the right 11. And square root underneath the y, that's how much we go up and down from the center, up and down. Okay, and so that's my box. And then my asymptotes are we go right through the diagonals, right through the center, 0, 0. Okay, those are my asymptotes. And my asymptotes have the equation, just like slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is change in y over change in x. So I square root underneath the y, square root underneath the x. So that's where I got this plus or minus 5 over 11x. And if you check it out, here's my plus b, y equals mx plus b. I go up 5 to the right 11. There's that one asymptote. And then from here go down 5 to the right 11. There's the other asymptote. Okay, so there's the asymptotes right there. And your asymptotes just tell you how wide your hyperbola is going to be. So it's going right there through that vertex right there, that vertice. And so that just tells me how wide that hyperbola is going to be. So now we're just going to, I call it flaring them out. They flare out towards the asymptotes right there. Ain't that a beauty right there, you guys? That'd be a nice tree ornament during the holidays as it spins around. Wouldn't that be a beauty spinning around? Huh? Okay. All right, sorry, you guys. Okay, this guy, they're both being squared. The x squared and the y squared. Okay, it doesn't equal 1, but check it out, you guys. And there's a plus sign, so it's either an ellipse or a circle. But since these numbers are the same, this guy is a circle. So circles, we want them to equal, the equation of a circle doesn't have to equal 1, you guys. We just have to get it to x squared plus y squared equals r squared. So let's divide everything by 18, and 288 by 18 is 16. So there's my equation of the circle right there. X squared plus y squared equals 4 squared. So my radius is 4. Okay, so if my radius is 4, I just did my little kind of boundaries buys. I did a little space up there, over here, down here. So there's my boundary. Now my circle kind of sucks. It's kind of a Fred Flintstone circle, but there's my circle right there. Okay, so I know I can do a better one on the Promethean board. All right. If you're in my class, oh yeah, don't forget, you guys, your distance formula and your midpoint formula, you're going to be asked to do something with that as well, okay? And if you're in my class, I would assign that for your homework. And if you find that these videos are helping, please click like. That would please me. Thanks, guys. Take care.